Thank you for joining today, the Harrington Group International Quality 4.0 briefing. The past, present, and future things every QA professional must understand. I attended the ASQ 4.0 event last year, and it was a great event. And I wanted to share some key points from several of the presenters, and then some of my own thoughts and insights. One of the presenters had a slide deck looking at what the CEO's biggest concern was. And interesting, the rise of disruptive technology was the highest over the cost of inflation. I mean, industrialization of AI is a mega trend that dominates not just the business landscape, but you see it on the news, you see it everywhere. And leaders are trying to understand and increasing their investments in artificial intelligence. But lack of knowledgeable people on this subject is one of the biggest challenges. And the point I'm going to make later is RI needs to come before AI. The other thing that was interesting, they said that 70% of young professionals get their training outside of formal schools to acquire the skills for 4.0. And the biggest challenge is that leaders don't have a clear vision about how to create value out of these big data projects. And we're going to talk a lot about that. But one of the things that this is really important. One of the things that you need to understand is your company culture in order to stand the environment you're working on. Anywhere from tech enthusiasts and innovators that rapidly adopt to the other side of the curve are laggards or followers that are just, well, let's wait and see. We're a little skeptical about it. And if you don't understand that, people sometimes get frustrated by what they perceive as a lack of interest on something like Quality 4.0, but it's really not that. It's just kind of the late adapter culture. I think this part of the whole subject is really important. And as a co-op student with the General Motors Institute, I observed two very interesting events that I'll never forget. The first one is we were in a pressed metal plant, and this is a long time ago, when robotic welders were first coming into plants. I was working as a maintenance supervisor at the time, and we were just having a real difficult time trying to get these robots to work. I mean, what should have taken a week, it was like multiple weeks and problem after problem. And I looked at a couple of the maintenance guys, and I go, why is it so hard to get these things to run? And they smiled and said, we don't want them to run. Same plant, same environment. This time I was an inspection supervisor. And we put in to the press metal line 100% inspection. We could check everything real time, in line. Again, this was state of the art at the time. And, if there's a problem, the line would shut down. Well, what happened is the line shut down a lot. So we turned, the operator just turned off the 100% inspection. And instead of really understanding the people and what was going on and talking to them, management came up with, well, we're going to put a red light. And anytime that inspection machine is turned off, we're going to have flash a red light. So what did the production people do? We put a red box on top of the red light so nobody could see it. The reason I wanted to share these stories is the critical importance of understanding people and the culture and what's going on before we try to throw some new technology at it. Well, some people call this bad news. Some people just call it reality. But study after study has shown that traditional quality philosophies have plateaued. They've stagnated and with little innovation to offer to manufacturing. We're talking about Six Sigma, TQM, SPC, all these things that have been going on for a long time. I don't want to say they're obsolete, but they're really not the areas to focus on. So quality professionals first need to understand top management and then show them how outputs that they're studying, whether it's financial data or other company goals, other key performance indicators. We have the ability to explain what makes those numbers go up or down. We must provide more value than we can. Quick example. Scrap on this particular product line went up last month. They know that, but they don't necessarily know why it went up. Or even better, scrap went down. We got better at it. But again, we don't really know why we got better at it. This is where quality professionals can shine. So the good news is we have the data. Quality professionals have more tools and expertise than most employees, and sharing these talents will give better insight. Here's just a couple examples. Compare program A in blue and program B in red. And we're looking at the number of engineering changes by product stage. Quality professionals look at this in a heartbeat and say, well, program B is going to have some problem. We did very little engineering changes in design, very little in prototype, but as soon as we started making it, we made a bunch of them. We know that costs money. Another example. By the way, when I say we know that costs money, the we is quality professionals. Not everyone sees that data or has that data to explain it. And same thing with suppliers. Program A versus program B. Program B, we brought in a bunch of new suppliers. We dropped a bunch, and we held on to some of them. But we know that changing suppliers just because we got a lower cost is risky. Tools for quality 4.0. This is a lot of information, and I'm not trying to educate on all these, but just to get an understanding of the terms so you know what they're talking about. Predictive modeling is a statistical technique to predict future behavior. And it uses a lot of data mining technology and looking at historical data. And again, this is where quality professionals can really, really help. We have it, and we just need the ability to leverage it. Network diagrams, again, not to get too technical, but there's arrow diagramming methods or activity networks, activity on the arrow, precedence diagramming method, node networks, all these terms, but just think of it as a better process flow with the ability to connect a cause and effect relationship that can be used to drive predictive modeling. Cluster analysis is another term you might hear. This is a data analysis technique that naturally occurring groups known as clusters. And a cluster doesn't need the data points in predefined groups. It just looks at it. It's an unsupervised learning method. Just show me a picture of this. And then sometimes this can be a real eye-opener because it shows things that people don't think about sometimes. Now, of course, a warning. Correlation does not imply causation, but if you've never done a cluster analysis of a bunch of your data, you should check it out. It's interesting. Text mining, also called text analytics, is artificial intelligence used to transform unstructured data into, from documents into a normalized structured data approach, which sounds great. But don't ignore, don't say, well, we don't have to have a robust database driven or robust system because we got all these spreadsheets and all these Word documents. Don't use it as an excuse not to take a step forward. But it is an interesting tool to be used in that. Discrete event simulation, just simulation, is another one that's really cool. It basically, if you organize it and control it well enough, what would happen if we did this? And then, event stream processing, again, kind of a cool term, but it's really alerts in real time, that says, hey, something's going on. We need to do something. I would recommend that the first use of this technology is people react, because we need people to teach the languages. There's a couple other terms you're going to need to be familiar with in this 4.0 conversation: Internet of Things, cloud computing, blockchain technology. We've already talked about AI a couple of times, and big data. Let's just look at those real quick. Internet of Things is again being used a lot, and it's great. And we're trying to connect devices with the ability to communicate. And this is good, but be careful, because if we want machines to do things without a human to human interface, start with human to computer interaction, because humans, again, need to teach in order to drive anything without human interaction. A way to think of this, think back to SPC, the idea, is it out of control? What if we could not just have what's out of control, but what should be done if it's out of control? And I don't mean just shut down the machine like that 100% inspection that I was talking about, but, do we increase pressure, decrease temperature? Are there things that we can do to make the reaction to an out of control situation smarter? Cloud computing. Somebody said this to me last week, and I agree with them. It's not that complicated. Cloud computing is basically using someone else's computers. Now, there's a lot of benefits with it. I mean, I didn't mean to be negative about that, but it's not that complicated. It can be great or unacceptable, again, depending on your culture, where you're at, what market you're in, what you're doing. But the reason I keep going back to culture is the company culture impacts decisions like this. I've had people say, we are absolutely not allowed to do any cloud computing. Again, this is the adoption curve, to the other side that says, we're moving everything to the cloud. Blockchain. A short explanation of this is blockchain is kind of a cooler version of data encryption. There's more intelligence and capability behind it. It's really about how do we transmit data through the cloud and have secure information. Artificial intelligence. Okay, here we go with AI. You're seeing it on the news and in the press. I mean, everybody's talking about it. And there's, again, depending on where you are in that adoption curve, it's either great or bad or neutral. You got to make sure with the environment you're working on. It's kind of the Internet of Things subject again, where application are driving decision making, but it's not that new. I mean, we've been using AI for a long time. Anytime you do a Google search, there's AI behind it. There's knowledge about searching, what other people search and what you want to see. There's knowledge about what you personally have searched and bringing up similar to it. You've probably seen that in Amazon, where you buy things and other buyers have liked this. Google Translate is an artificial intelligence trying to go through that. But if we go back to the SBC example, remember, not just when to react, but how to react. Again, shutting down is easy, but if we can get smarter about, if this happens, this is what you do to get it back in control. That's pretty cool. I mentioned the term RI in the intro. And I really want to make sure that people understand artificial intelligence is great, but we have to recognize real intelligence, or what I called RI. We need RI in order to get to AI. You know, the risk is artificial intelligence is driven by learning, and who's teaching it? And the example is a lot of people give when they talk about AI is, well, machine learning on chess, it does all the moves, it loses, it remembers, it does all the moves, it loses, and millions and millions of transactions, it gets really smart. That's perfect. But it's not the same as trying to explain and understand the manufacturing process, all the process variables, all the machine sensors information to say, if this happens in an SPC reaction thing, this is what we need to do. Remember, the robotic welder and 100% inline inspection story. Real intelligence from people is critical to drive artificial intelligence. Big data analytics. This one's really important because if you don't break it up into pieces, which is the whole point of this slide, we've got all sorts of data and we don't know what to do with it. We got, millions and millions and lines or rows of information and thousands of spreadsheets. We don't know what to do with it. Big data needs to be properly collected, cleansed, stored, formatted, and accessible in order to get to where we want to get, and that's decision making. My son is a data scientist, and when he's working with data, he told me that he has 500 terabytes of data that he's going through. That's a lot of data. On the other side, my daughter is the one that takes that data and does the analysis and does the data storytelling. And just this morning, about 2 hours ago, her executive on the call said, I've never seen data insights like this before. That's exciting. When you get the executive of a large company to say, boy, is this helpful. I've never seen this before. The reason I shared the two stories is because even this subject, there's two skill sets that are needed. My son, who has the ability to go out and collect 500 terabytes of data. And then my daughter, who has the skills to visualize and analyze it and tell the story. Very exciting subject. Just wanted to give you some pointers on understanding it. We've come a long way. Access, display of information, and just using this example, we went from VCRs, then we went to CDs, and now we're on demand. But most importantly on this slide is the cost has come way down. I mean, I can't even think of telling somebody the story about working on 500 terabytes of data in 1973 or even 1998, maybe even 2008. But fast forwarding today, what's available and the cost of it is pretty exciting. Predictive analytics. This is the greatest opportunity for quality profession is predictive. We have the data, and we're one of the few professionals in most companies that can explain why the business metrics go up and down. Again, back to, the scrap went up last month. Why? It went down last month. Why? Just knowing that it went up or down, it really isn't that as critical as why did it so it can repeat it. This is the new frontier. Six Sigma, Lean, TQM, SPC, whatever things are going on, those are the old VHS tapes. We need to move forward. So for quality point or 4.0 focus, always keep in mind your audience based on the company culture. Otherwise, you will get frustrated. We need to enable people to communicate better, faster, and get to that prediction, decision-making capability. The other thing that, again, this is good news. Quality professionals have a great amount of RI, real intelligence that's needed for AI. So, the quality future is bright, excuse me, if you're willing to learn more, learn new things, learn new, unlearn the old, get rid of the old paradigms, understand the technology, which is why I'm hoping a lot of you are joining today. And absolutely, without a doubt, leverage real intelligence. I didn't know if I had to put this slide in or not, but, well, we don't like change, I'm kind of a Star Trek fan, and one of my best quotes from Spock is, "It is illogical to assume that all things remain constant." Even going from a typewriter to a computer, going from a word processor to ChatGPT. The biggest thing that I added was, we don't like change. I'm going to use a telegraph. I'm not going to use a phone. And I'm not. How would the world react if cell phones stopped working? My wife works at a high school and just told me a story about a parent, not a student, totally freaked out about losing their phone. I mean, like high anxiety, just horrible. So I guess the point of this thing is, it is illogical to assume that all things remain constant. And those that adapt quickly win. This is another pointer from the Quality 4.0 Summit. 42% of the challenges are what we're talking about today. 41% is on culture, which is what we're talking about today. 35 is proper use, lack of data. Lack of data, again, 500 terabytes is crazy, but that's what we're talking about. 33% are people knowledge and skills and awareness. All things we're talking about today. I found this slide very interesting from the conference. Machines can learn faster than people. Okay. It's exponential. People are more linear, regardless of the company culture. The human brain is kind of linear. It adapts slowly over time. So people need to adapt, and it takes time. Remember the robotic welding inspection story? It just takes time. By the way, if you go into the plant that I was at I won't tell you when, but a long time ago, it is all robotics. It is all machine vision, but it took time to get there. So the journey from reactive to predictive by people is supported by this technology. But again, it just takes time. I found this slide very interesting. Do we need new job descriptions? Everybody know that pay motivates behavior. Behavior is controlled by job description, sort of, most of the cases. But the biggest thing I got from this when I saw this slide is we need to get out of the culture says it's not my job and replace it with how can I help you? Very interesting paradigm shift. So you've heard me a lot in this. People. Human factors is critical. People first, then the process, then the technology, in that order. I have had conversations, very frustrating conversations, very expensive conversations about slamming new technology into poorly defined processes. It doesn't work. It's bad. So take baby steps. Even for the early adopter cultures, the people that rapidly say, yeah, let's do it, still take the baby steps. Jamming stuff that can adapt and change faster than humans is tough. This was another slide that I thought was interesting. Data is the new oil. I hear that from other people. So data refining is critical to get the gas we need. And predictive decision making is the new journey. That's where we're going to go. So having a bunch of oil is cool, but if I can't get it to gas, it really doesn't do me much. And if I'm not going anywhere, it doesn't matter. Let's take a very specific one. Let's talk, and I apologize. I know we've got some people on today's event that aren't necessarily familiar with this, but PPAP, or the production part approval process, is a technology that was created a long time ago, supported by the automotive industry, aerospace, medical device, a lot of different consumer products. Everybody's kind of looking at it. But regardless of the industry you're in, even automotive, that's been doing it for over 30 years, the majority of that information is in spreadsheets. So call that 1.0. How do I go to 2.0? Well, get out of a standalone, non-integrated, error-prone data spreadsheet and put it into a database. Good baby step. Good simple step. 3.0. Once I get in a database, then we can look at human and IT and restrictions, single sign-on, integration with other tools. And by the way, analytics that you have never been able to do with thousands of spreadsheets scattered across multiple file locations. And then we can talk about 4.0, because there's a lot of cool things we can do with all that data. But the purpose of this slide is, I've been asked for and talked about, well, how do we apply 4.0 to the PPAP process? So where are you at now? Oh, it's all in spreadsheets. It's a mess. All right. Well, you can't go from 1.0 to 4.0. So, analytics, and just get a little more examples of this. I've been talking with a lot of aircraft manufacturers, and an aircraft engine has about 30,000 manufactured parts in it. And let's say it's coming from 3,000 suppliers. So you probably have about 9 billion lines or rows of data in all these standalone spreadsheets. But what you don't have is the ability to know if the data is working. I mean, is the whole PPAP process working? Are we reducing occurrence? Are we improving detection? Reducing failure costs. So we got to have a better way to do that. And again, you can't get to 1.0 until you do the first part. And what about predictive? What if we are looking at this and say, wow, if we can connect this to other data like nonconformance or those Internet of Things or machine things, shutting down equipment, wow, this is happening a lot more than we thought. We put an occurrence at a 1 and it happened 30 times last week. Or detection. We put in machine vision, everything's great, 100% inspection. But we're seeing that it's being discovered at the customer, not us. Failure modes. We're going through this. Say, have we seen this before? Not only have we seen it before, but how did we fix it last time? So again, think of these storylines building about, what if I had the ability to have not a bunch of spreadsheets, but a data model that I could start doing this on? Failure costs. Boy, if this is happening more than we thought, it's being discovered by the customer, and it's happening over on this product line, but not this product line. What did they do? Did they error-proof it? How did that work? So, but by the way, this is a space that a lot of quality engineers and manufacturing engineers hang out in. And they're thinking all these things. They're trying to analyze all these things. But until they go from 1.0 to 2.0, they can't pull it off. So there's a progression. There's a progression that says we go from manual spreadsheets into these enterprise quality apps, connecting the quality apps with ERP, PLM, MES, all the Internet of Things probes, all this stuff, bringing it together. Visibility, so seeing it in real time. Telling me that there's a big problem a month ago really doesn't give me the ability to react to it. Transparency, and I don't mean that term generically, but if I don't have access to this, I can't do anything with it. And then all that predictive capability, the FMEA and control plan examples I just gave. And if you want to stretch it, self-optimizing, the ability to go through and do all this stuff, cool stuff. Key takeaways. SPC, TQM, Six Sigma, Lean, kind of obsolete. I don't want to bum you out. I know there's a lot of people that just say that, but if you look at how the history of quality has evolved, other things show up, other things happen, and quality 4.0 is one of those things that it's not coming, it's here. People are talking about it, they're trying to understand it. And companies that deploy will be competitive. But smart manufacturing requires quality professionals to innovate and create new business-driven solutions, and we can. Remember my daughter's reaction to that. I've never seen information like this before. By the way, it wasn't just data she presented, it was information, it was knowledge that you can use with decision making. What we all have to have, all quality professionals have to understand, here's the culture I'm in, here's 1.0, here's 2.0, here's 3.0. How do I begin the journey? With that, let's check to see if anybody has any questions. By the way, Harrington Group offers and has been in business for decades with tens of thousands of customers around the world with supporting tools like this. So let's see if we got any questions. Okay. Our culture is mixed based on which executive you talk to. How do you manage that? That's a great question. That technology adoption curve, I was talking about the complete culture, but within your company, you'll have mixed thoughts and people on it. Here's what we need to do. First of all, the fact that you understand that is great. Now that we understand it, if you're trying to be on the innovative curve, the early adopter curve, and you have a key executive that understands that, you need to leverage them. You need to ask them specifically, how do we engage this person who is still in, the 30 years ago mindset that doesn't want to change, that doesn't want to break? The two of you are better than one. You find another one that's better. But in those conversations, you need to understand why the people are behaving that way and be able to adopt. Let's see, we have just one more. I agree on what you said, but I can't get funding to get off 1.0. Our current quality manual is manual, some spreadsheets, but I can't get funding. I think part of this challenge is, again, that first of all, understand your company culture. I'm guessing you're on the late adopter stage where, a lot of people have done this, but you're frustrated because you can't. One of the things that's really important is you have to be able to sum the financials and the ROI and the idea of, if I give you $1, how much am I going to get back? That's just kind of the ROI conversation. But the other one that's really important, and the Harrington Group really supports this, take baby steps. If you're trying to bring in an enterprise quality system like Harrington provides and jam it all into the company at once, first of all, we already learned that humans can't adapt that fast. But other ones, it's expensive. I mean, the ROI in some kinds is just tough. So take baby steps. I mean, Harrington, because of this, has put together a starter kit. Here's this big enterprise app that has a bunch of stuff in it. But you know what? Let's just start small. And traditionally, people start with, well, let's do document control. And then let's do training based on the document. And then let's do audits to make sure they're following the documents and the training was effective. And then let's do corrective action based on what we find. You got to take baby steps and to make sure all this works. Okay, thank you so much for attending. Appreciate it. I forgot. If you have any questions, please reach out to me on LinkedIn. My email is jcachet@hgint. Thank you so much for taking your time. Have a great day.